In this video, we're going to talk about how to evaluate functions using function notation. So once you've determined that a relation is a function, you can describe it using function notation. So let's suppose we have the relation y equals 2x. And now once you've graphed this relation and you've used the vertical line test, you can figure out that it is a function. So instead of writing y, you can write f of x. That's how this is read, f of x. And that f of x will take the place of y, and so f is the name of the function, x is the input, and so this 2x tells you that this function is doing that. So this function is going to take all the input x values and multiply them by 2. So if y equals 2x minus 1 is a function, let's rewrite it using function notation. So this is the graph of y equals 2x minus 1. You can see using the vertical line test that this graph is a function. So instead of writing y, you can write f of x equals 2x minus 1. And so when you name your function, f of x is the most commonly used form of function notation, but you can use any letter that you like. Instead of f of x, you can call this function h of x and say that h of x equals 2x minus 1. You can also use capital letters. You can say that g of x equals 2x minus 1. So you can name your function using any letter that you want. So let's try some problems where we have to use function notation. What is the value of f of 1 for the function described in the table? So f of 1, let's think about what this is asking us. So remember that we're talking about f of x notation. Okay, so if we say f of 1, that means that 1 has taken the place of x. So that means that x equals 1. So it's asking us to figure out the value of f when x equals 1. So we're going to go to our table and find x equals 1. Then we're going to look for the f value that corresponds to that 1. And that is f of x equals 3. So that means that f of 1 equals 3. So let's use function notation with a graph. What is the value of f of 0 for the function described in the graph? So once again, let's think about what this is saying. We're talking about f of 0. So since we're talking about f of x, we know that we're looking for what's happening when x equals 0. Remember that f of x took the place of y. So trying to find f of 0 is basically like saying, what does y equal when x equals 0? So to figure this out, we're going to go to our graph and find x equals 0. So that's this point, 0, 2. So that means that when x equals 0, y equals 2. So that is the value of the function at that point. F of 0 equals 2. So we can also use function notation with equations. To evaluate a function given an equation, we're going to replace x with a specified number. So if we're evaluating f of 2 when f of x equals 3x minus 2, that means you're going to substitute 2 into the function in place of x. So we would do this by saying f of 2 equals 3 times 2 minus 2. So now we just have to simplify this expression. So we have 3 times 2, which is 6, and then minus 2. Then we have 6 minus 2, which equals 4. So we have f of 2 equals 4. So order of operations is going to be very important when we're solving these problems, because sometimes these equations can get a little complicated, so we're going to have to use order of operations as we work through and try to simplify. So we're going to start off doing anything that's within parentheses, then work with any exponents, then multiply and divide, and finally add and subtract. So if f of x equals 3 times x plus 2, what is the value of f of negative 4? So the first step in these problems is always going to be to plug in for the value of x. Negative 4 is going to take the place of x, so we're going to start off by plugging that in. F of negative 4 equals 3 times negative 4 plus 2. So we're going to start off by simplifying what's in parentheses. So we have negative 4 plus 2. So this is going to become 3 times negative 4 plus 2, which is negative 2. Now we're going to do the multiplication. So we have 3 times negative 2, and that is negative 6. So f of negative 4 equals negative 6. So if f of x equals negative 4 times 3 minus x squared plus 1, what is the value of f of 5? So you always start off by substituting. F of 5 equals negative 4 times 3 minus 5 squared plus 1. So once again, we're going to start off with simplifying what's within the parentheses, which is 3 minus 5. So we have negative 4 times 3 minus 5, which is negative 2 squared plus 1. Now we're going to work with the exponents. So we're going to do this negative 2 squared. Well, I'm going to make a note about this. This negative 2 squared. Remember that squaring a number is multiplying that number times itself. So negative 2 squared is negative 2 times negative 2. And that is positive 4. So we have to be careful about this because if you just type this into your calculator as negative 2 squared without the parentheses, your calculator will solve a different problem. Your calculator will do order of operations, and it'll do 2 squared, which is 4, and then multiply it by negative and tell you that this is negative 4. But that's not the problem we want it to solve. We want it to square negative 2, so if we're entering this in our calculator, we have to use the parentheses. So now let's go back to this problem. So we have negative 4 times negative 2 squared, which is 4, and then plus 1. Now we're going to do our multiplication. So we do negative 4 times 4, which is negative 16. We still have plus 1. Now finally we do the addition. So we have negative 16 plus 1, which is negative 15. So f of 5 equals negative 15. So if f of x equals 3 times x squared minus 2 plus 10, what is the value of f of 15? So let's start off by plugging in 15 for x. So we have 3 times 15 squared minus 2 plus 10. So let's start off with our parentheses. So in this problem, our parentheses tells us 15 squared minus 2. So even within the parentheses, order of operations still applies. So we're going to do the exponent before we do the subtraction. So we're going to start off by simplifying that 15 squared. And you can use your calculator for this. You can type in 15 squared, and it should tell you 225. So we're going to plug that in. So we have 225 minus 2 plus 10. So we're not done simplifying what's within the parentheses yet, so we're going to continue with that. So we have 3 times 225 minus 2, which is 223, and then plus 10. Now we're going to skip exponents because we don't have any, and we're going to go to multiply. So we're going to do the multiplication first. So we have 3 times 223, which is 669, plus 10. Now finally we can do the addition. So we have 669 plus 10, so that's 679. So f of 15 equals 679. So if f of x equals x squared plus 7x, what is the value of f of negative 3? Well, this problem is a little bit different because here we don't have an x in one term, we have an x in two terms. But the idea is the same. We're still going to go and we're going to plug in negative 3 everywhere we see an x. So this means f of negative 3 equals negative 3 squared plus 7 times negative 3. So we're going to start off by simplifying the exponent. So we have negative 3 squared, which is positive 9, plus 7 times negative 3. Then we're going to do the multiplication. So this is 9 plus 7 times negative 3, which is negative 21. So I have this double sign right here. I have plus and negative. So I'm going to turn that into a subtraction sign, 9 minus 21. And so that is going to equal negative 12. So f of negative 3 equals negative 12. So if f of x equals x plus 2, what is the value of f of x minus 1? So here's a totally other situation. I'm not given a number to plug in. I'm actually given an expression. But once again, it's the same idea. The only difference is I'm going to take this entire expression and plug it into this equation where I have x. So this is going to say that f of x minus 1 equals x minus 1 plus 2. Notice that this x minus 1 took the place of x in my original equation. So now all I need to do is simplify this. So when I simplify, I'm going to combine these like terms. And so that equals x minus 1 plus 2 is going to be plus 1. So I have f of x minus 1 equals x plus 1. So if an equation represents a function, you can rewrite it using function notation. You can use function notation to evaluate a function at specific values. Just plug in the given value for x and solve.